In this video tutorial, we're going to step through importing an asset into Unreal and letting Unreal automatically generate collision. We're going to go in and we're actually going to customize that collision to better suit our needs. We'll step through the process of auto-creating convex collision. And then lastly, what we'll do is we'll actually step through creating our own custom collision geometry inside of Maya and importing that object so the engine recognizes our own custom as opposed to auto-generated. Let's get started. The first thing that I want to do is we're going to import our custom mesh as it is and let the engine handle the collision out of the start. So we'll go ahead and just drop this in here. And with it, what I'm going to be focused on here is this auto-generate collision. So I'm going to keep that checked. We're not really worried about any of the other settings in here, and let's go ahead and import. All right, so let's open this up and we'll start kind of taking a look at the asset and see what's happening here. So the first thing that I want us to be concerned about is the collision over here, and then also our drop down to be able to view it. Now, before I jump into the simple collision that we're going to use, I do want to make mention of this complex collision. This is something that tells the engine to use the actual visual geometry as your collision. I will tell you that it's probably very tempting to want to use this as your collision because you're like, oh, this is perfect. You know, it follows exactly the lines on my geometry. It means I'll get exact, perfect collision with the player. I will tell you this, don't do it. At all costs, try to avoid using your complex collision. The primary reason for that is in terms of the engine performance. Using complex collision is very, very costly. And so ultimately what this means is that if you've got a bunch of objects that have complex collision on it, it's going to drop your frame, your actual frames significantly because your frame time on the back end is going to be higher as the engine's trying to process all of these data points for collision. So as a general rule of thumb, you don't want to use complex collision. Instead, you want to actually have good, simple collision on your meshes, which is what we're going to be stepping through. So, but it just bars worth noting that if you're wondering what complex collision is, that's what it is. So we'll uncheck that. The second thing with complex collision to make note of is on your actual asset, you can set this as your project default, and you can also set it per asset. I will tell you this, if you're coming onto a project that say you're helping out with or something, and they have this use complex collision as simple, don't be a jerk about it, but I would probably bring it up, you know, hey, you guys are aware that this is the default. That's going to be set on all the assets. So that's where it'll also show up here, and then of course use simple as collision as complex, simple as complex. However, I recommend just keep it as project default, but just know that you can set it per asset. So okay, so the first thing I want to do is show simple collision. Okay, so hopefully this is visible here. This is the collision box that the engine has set for us by default. So when we had that checked, it's going to go through and it's going to create this. And there are many situations where, you know, the auto-generated collision works absolutely fine. In this case, it's not bad. If this were like maybe say a distant rock that, you know, you were going to throw a ball at or something, maybe this is good enough. So I'll go ahead and save this. And the second thing that I want to show is our actual visualization of this. So if I drop this into the level, we have our small rock base. And underneath, I'm going to go under our lid, and I'm going to go to our, I believe it is visibility collision and player collision. So if I go to player collision, let me drag this back over. You can see that the two are perfectly matched. I don't have this lined up. Actually, I guess that is kind of, might be close to the way the asset was dropped in. But there it is. So this is the collision that the player is going to hit. So as they're running in, this is what it's going to be. So in the situation of, you know, how do you determine if your collision is good enough? You can jump in, play it, run into it, see if it's good enough, or visually you can kind of look at things and go, okay, does this make sense? You know, so if like we kind of take a look here at, you know, let's say this right section here, this corner. You know, as the player is coming up to this rock, there's kind of that invisible wall that they hit, right? Because this corner sticks out way too far. So in that situation, just based on kind of a visual look, I'm going to assume that this collision probably isn't good enough if this is something the player is going to be able to walk up to interact with, to touch. This isn't going to work. So let's move on to the next process, which is still using the tools inside Unreal, But let's go ahead and modify this collision geometry to suit our needs. The first step that I want to take when it comes to kind of creating our own custom collision inside Unreal using the Unreal tools is I want to get rid of this old collision. So I could select it with the mouse. It's something to note in this viewport. It's very similar to the working viewport we have in Engine, where you can select things. We can also go in and we can change our cameras, which we'll probably do when we're setting up collision. But we can select it just as we would any object. However, you do have to note that you kind of have to select the wireframe of it. Otherwise, it doesn't really select. So we'll select the wireframe and we can press delete. Or the other thing is, say, for example, we have multiple collision objects. We can just go under here and we can say remove collision. So under the drop down, remove collision. Okay, there we go. So now our object has absolutely no collision on it. So how do we go about adding these collision volumes? So there's a couple things we can do. We can go into collision. And in here we can see a couple things. I'll go over the first three and then explain what the rest of them are because they're very similar. So the first thing is add a spherical collision. So if we add that, if you notice, it creates the sphere collision based off of the whole volume. So it tries to fit that collision over the object to encapsulate it as much as possible. That sphere, we've also got a capsule and a box. One thing that I do want to make a note of in terms of performance and cost is that when we add these collision objects, so a sphere, a capsule, and a box, it's important to understand that when we're adding them through the actual engine tools themselves, these are mathematical representations of kind of physical geometry. What do I mean by that? You know, we could go into Maya, which we will a little bit later, and we could create a capsule ourselves, we could create a sphere, we could create a box. When we use the tools, this is actually creating a mathematical representation, which means it's not actually associating faces and vertices. So by adding the sphere, capsule, and box collision in Unreal, it's cheaper in terms of your performance cost than if you were creating your own custom inside of Max, Maya, Blender, whatever you want to use. So just important to note. So, okay, so I've got this capsule here. Now, if I've got it selected, which again will kind of be this lighter green, I can go in and I can move it. I can scale it, and of course I can rotate it. All of these tools. You may have to uncheck some of these so you don't have snapping, but we can adjust this volume as much as we want to. So for example, I could go here, I can go into my top view, I could zoom in and I could try to, adjust this a little bit, take it in and out, whatever you want to try to fit this to the appropriate side. As we'd kind of mentioned before, really what we're trying to solve by creating our own custom is a better representation of how we would collide with this object, right? So I could take this guy down, I can move him out here. You can hold Alt while dragging and it will duplicate. I think you can also do, Control W with it as well. But we can go in and we can kind of scale this, and now this is our collision. So if we look back in here, and let's go under our lit, we go to ability collision. Actually, I'm sorry, we'll go to player collision. There we can see what we've adjusted. So if I move this, you can see that it's adjusting the collision. So that's exactly what we wanted. I'll make a note, if you guys saw the other collision that's in there, that's actually because I have a couple other things hidden in the background. That's not a rendering error, it's just those are other objects in the scene as well. So okay, so that's kind of the first bit here where we've got our sphere, capsule, and box collision. So what are these DOP? So I'm going to go ahead and just remove my collision, and let's just add one. So let's just say that let's add this 18 one. Okay, so this is very, very similar to what our original when it auto-generated it. And if we were to go in and actually count the points of precision on here, it would actually align with our 18 points. So that's what these things are stating. And again, the advantage of using this type of collision is it's more of a mathematical representation as opposed to actual physical geometry. If you're an artist and you understand what an n-gon is, obviously we couldn't create this this particular polygon, right? Because it's got 1, 2, 3, 4, 5, 6 sides on here. However, in the engine, again, this is a mathematical representation. So again, cheaper, but this is just adding more points. So let's remove this guy. So select and delete, and let's also just add a 26 points. So again, if we were to go in and count each of these points, we would see that it would be it should add up to 26. So versus our 18 that it originally came in with, this is a better representation, which is still pretty good, but we can actually go a little bit further and make it even better. So so those are kind of just the default boxes that you can add, or I guess I should say default shapes. So I'm going to go ahead and remove the collision again. So under here, we'll do collision. This is the last bit. This is the auto convex collision. So it will open up this setting. Okay, so to explain a little bit what's happening here, I'll preface that there's really nothing that says you're going to get this perfect each and every time. I still don't know 100%, in particular with this hole precision. The hole count and max hole verts, I can tell you that I know exactly what's happening with that. With hole precision, you just got to play with it a little bit. So let's explain what happens here. So hole count. One thing to note about your collision is that collision has to be convex as opposed to concave. So if you think of an orange, it's a perfect sphere. That is convex. Concave is any time that you have a divot, right? So something goes internally. Your collision cannot be concave. It cannot have a portion that's inset from the others. So when we use this convex kind of auto creating the collision, it's going to go through and it's going to create these convex, not concave, convex. So perfectly. There's no divots in it. It's going to create as many of these as it needs to be able to maintain the shape that you said. So with that, it's going to create a bunch of these. So if we, the example we had with our boxes, right? It's going to create multiple boxes around this to best fit the shape as it processes. When it does that, it's for each of these, what it's considering a hole, it's how many, the counts do you want on it. So in this case, 4. So it'll create 4 objects to try to encase this. So, in the situation of our rock, I'm going to say I'll probably need more. So I'll bump this up. Let's say 10. Max hole vert count. So as it's going through and it's processing this, the max hole vert, so the number of points on there, that's what it's going to associate with each of those to try to best fit. Now, if you remember what I had said earlier with collision, you don't really want to have a high, vert count, high hole vert count on your collision, because the more verts that you have, the more it's going to require the engine to process all of those points of collision. So in this case, where we've bumped up our hole count, I may want to drop this hole vert. So let's say that I bump it down to 10. So again, if we're placing a bunch of cubes around here to try to best fit this shape, each of those holes, maximum number of verts it can have is 10. Okay. And the last bit here is this hole precision. It's an arbitrary value. I'm not sure why they have it set at the thousands. I think the easiest way to think about this is a slider from 0 to 100%. As your precision goes up, the engine is going to process the object itself more precisely, so it tries to match that silhouette. So as a general rule of thumb, I would say that, if this is an object that's in the background and maybe something will hit it, maybe it won't, our hole precision we're probably not too worried about. Now, again, let's say that this rock is being used as for, like a first-person shooter where, the player is going to be right up against it and we want as much precision as we can. I would take this up much higher. So we'll just set it at 90%. We'll call it the hole count of 10, max hole verts of 10, and we'll apply, and let's kind of see what happens here. So the engine itself is going to go through, it's going to process, the shape, and it's going to create our collision. So there we go. Not too bad. So we can see here if I select, this may be a little difficult to see. Simple collision will show by default when you process this, just be aware of that. But you can see as I'm selecting these, you can see that there's multiple holes along this thing, holes as in H-U-L-L. Each of these different pieces of collision. So, let's go ahead and take a look at this now inside of here. So let's go into our player collision. So there we can see the representation of the rock. So if we go back to our lit mode, we'll go to our collision. You can see that it is definitely much better than our auto-generated or when you try to create all of those shapes. So the next process I want to show you is what happens, if this isn't good enough. So let's just say, for example, that, the hole precision, this is too much, or, maybe we want, more hole vertex, to kind of help better do that shape. I can just go ahead and apply, change it. If you notice that when you do this, the engine will automatically delete all of your collision and then re-add it. So you don't have to go in there. You don't have to do collision, remove, and reapply. Once you reapply the tool, it will do it for yourself. So, okay. Personally, for me, I think this is a little bit better collision on it. Again, assuming that we're coming from like a first-person shooter role where they're going to be up close, hugging the rocks, needs to have good precision. That gets us pretty close. So, again, just to recap real quick on this little section, we have the ability to add our own collision here, or we can use this auto convex collision, which will open this tool and it'll run through. You can set your hole count, max hole verts, and your precision. Okay, so the last bit that we're going to cover here is, what if I want to create my own custom collision inside of, say for example, Maya, Max, Blender, whatever you want to use, and I want to use that geometry as my collision. That's the process we're going to set through next. So we'll jump over to Maya, and then we'll kind of go through that whole process. All right, so now we're in Maya, and we can see here we've already imported that rock that we had as kind of our base mesh, and we just named it SM Rock. I'm just going to step through, not necessarily how you model a collision, but we'll show you how you can take the geometry that you want to use for your collision and actually export that out. So when you're importing the object, the engine recognizes, hey, this is collision, not visual geometry. So I'm going to pop up on screen here real quick so you guys can see. This is from the Unreal docs on custom collision, but there's two things to cover here. The first thing that we covered kind of in the last section here is this idea of convex versus concave collision. Again, concave, you can see here represented by, whether we have holes or the geometry itself, indents. We can't have this. The engine will actually ignore this and simply complete the actual shape itself. So you can't have any of this concave geometry. However, you can have convex. So as you're going about, creating your custom collision for your meshes, my recommendation would just be stick to boxes and spheres. You can use capsules as well, but boxes and spheres will probably be your most likely objects that you'll use. Now with custom collision, there's nothing that says you can't create several pieces of those. So, say for example, you've got a window, you want the player to be able to jump through, and you want to create, the custom collision. Obviously you're going to need, a box on each side and a box top and bottom. So right there, we, already have 4 boxes for our collision. That's totally fine. The second thing that I want to mention here, again, all this is inside of the docs, is your naming convention. Now, for this one, we're going to use UCX, which is going to be for our convex objects. You can assume it's like, kind of custom. But UCX as our naming convention will be our custom. You may just use that in general. It's just easier to do. However, if you do name your meshes, again, your custom collision inside of your DCC program, UBX, it'll automatically create a box. UCP will be a capsule, and USP will be a sphere. If you remember what I had said kind of in the last section here, when we were creating our custom collision inside of the Unreal tools, we were able to select from the drop-down a box, a capsule, a sphere. Those were mathematical representations as opposed to actual physical geometry. That's what this UBX, UCP, and USP will do as well. When you import, it will create those mathematical functions. So again, this could be cheaper than if we use UCX, which again tells the engine that it's going to be using the faces and the vertices as opposed to the mathematical representations. So just be aware that, if you're creating a bunch of custom collision inside of, say, Maya, Max, or whatever, and you're naming, things UCP underscore your mesh, it's going to create a capsule. USP will create a sphere. So just be aware of that. But for the purposes of this example, we're just going to name everything UCX. So before we jump over to Maya, I'll just show you real quick how this works. So our prefix will be UCX underscore. We'll have our mesh name underscore followed by our actual numbers. Again, that's where I said you can have multiple numbers of these, collision things. In the case of the window, right? 4. So we'll have, 01, 02, 03, 04, so on and so forth. So again, you can find these in the Unreal docs under custom collision. So let's jump over to Maya real quick. So Okay, so how do we set up this custom collision, right? How do we get the engine to recognize that, this is collision? Has nothing to do with materials, has everything to do with our naming convention. So in this example, our asset is called SM_rock. It's important to note that you have to use the exact same name. I believe it is case sensitive as well. So the best bet is just, Control C, copy the name of it. And then we'll apply that to our a custom collision. So first example here, and this is a bad example, and I'll explain why here in a second. So with our first example, we've got two kind of overlapping spheres, right? So one sphere, I'm going to name UCX_SM_rock_01. Again, so if we were to rename this, I would just copy SM rock, put the prefix of UCX_, and then under the suffix would be our numbering, so _01. It is important to note too that you keep your numbering. I would not do SM rock _1. I would do 01 or 001, and you keep that chain going. Using two numbers as your suffix should be totally fine, because that would give you a theoretical, I think, 100. If you started at 0 and went to 99, that would give you 100 pieces of collision. Shouldn't be any reason why you would need more than that. Okay, so in this first one, I said that this is a bad example, and I'll explain why here. So we've got two pieces of collision, rather simple spheres. But if you notice, they're actually penetrating into each other. This is very bad to have with collision. This will actually cause some issues with the engine. It will cause this particular asset, when we import it, to spend more time processing because of those two objects, right? We've got collision inside of another collision, which could be very problematic. So when you're setting up your collision, don't do this. So I'm going to go ahead and hide this, and I'll show our next one. So first thing I'll show you is that, we've got three pieces of collision here. And if you notice, kind of at the side, that there's a bit of space in between the two of them. So that's good. That's what you want to do. It doesn't have to be a ton of space, but just offsetting each of those collision pieces from each other is a very, very good practice to get into. So, okay. So with that, the shapes, again, I use cubes, very, very simple. I've kind of encapsulated. The point here is just to show that when we import this, we're getting our custom collision. So with that, I've just named these, UCX_SM_rock01. So the next step is I would go ahead and just select all of my assets that I want, and I would export those as an FBX. Exact same pipeline you're probably already used to. Export it as an FBX, have your settings, that's fine. There's nothing else special about the export process. The only thing is just our naming convention here. So let's jump over to Unreal, and we'll import this and see how we get that collision. All right, so in Unreal, I'm going to go ahead and just import this custom one. Now I just export it as an FBX. Really the only thing that I want to make sure of is this auto-generate collision is unchecked. I tested this a little bit earlier, and I believe in the engine now that if you're exporting your FBX model with custom collision, the engine will auto-recognize you have custom collision and will automatically disable this even if you have it checked. However, just as a safe bet, let's just uncheck it and we'll import. And we'll open this and let's take a look. So, okay, so here was the mesh that we imported. So I'm going to do my collision and simple collision. There we go. So there's our custom boxes that we created. And like we saw in the previous sections, I can go in, I can select one of these, delete them, just as I would anything else. But there is our custom collision exported out of Maya. So that kind of concludes this this video tutorial. I hope it helped. Hope you guys learned some things. Again, you may find that the auto-generated collision works in most situations. The next go-to would be, under your collision, auto-convex collision. Typically, that'll get you about 80–90% of your assets should be totally fine with that. But in the event that you find you need to go in and actually create custom collision, again, I'll pull this back up. It's in the Unreal docs. You can find it. But that is your naming convention to associate with each of your things. Make sure that it is convex, not concave, and you should be golden. So that covers this video tutorial. If you guys have suggestions for future videos, absolutely drop them in the comments. I'll see what I can do to make those happen. So I appreciate you guys watching and supporting this, and we'll catch you on the next one.